In this video, we're going to cover 14 essential front-end system design concepts that will make your applications faster, scalable, and more efficient. So whether you're prepping for a system design interview or improving your dev skills, this video has got you covered. So if you're interested, let's get started. Now, before anything else, we need to decide how our application should render the content. So there are 5 main different strategies that we can use. And first one is the static site generations, which pre-builds the page at build time, which has the fastest performance to load the page on the client. Then we also have incremental static regeneration, which updates the static page on demand without a full rebuild. Then we also have server-side rendering, which generates the page on each request, which is more suitable for dynamic content. We also have client-side rendering, which loads a blank page of HTML first, then fetches data and compiles the JavaScript code on the client side. And lastly, we also have partial pre-rendering, which mixes the pre-rendered and dynamic content on the page. And of course, if you want a deeper dive on these 5 different strategies, then please check out this video that I made called Master Web Rendering Strategies, where I explain in detail on how these different strategy works. So let's say we chose the right rendering strategy and which our front end start to grow. Maybe our deployments start to become riskier because our code start to get larger and every small changes could have a higher potential to break. Then that's where the micro-frontend architecture comes in, which solved this by splitting the application into independent and deployable pieces. And each of the micro-frontend applications can have its own rendering strategies, like static site generations for the product pages, or server-side rendering for checkouts, and client-side renderings for chat communication, for example. And the key tools for micro-frontend application is module federations using Webpack 5, which dynamically loads different micro-frontend applications in the page. And of course, on my channel, I also have made a video called Micro-frontend Architecture Setup and Key Concept Explained. So in that video, I dive deep into how the architecture works, as well as how to set up a micro-frontend architecture locally on our local machine. So if you're interested, please check it out. Alright, so now we have talked about the rendering strategies and how we can be able to scale the application using micro-frontend. Let's talk about how we can actually measure and optimize our rendering performance. Because if our application is slow, then users won't wait around. But before we optimize anything, we need to find out what's slowing things down. We can use Chrome DevTool Performance tab, and this lets us to track the first contentful paint and time to interactive, basically how long it takes before users see or interact with our application. And we can also be able to use React DevTools Profiler to show which component re-render too often and where the slow parts of our application is. And then we can also use Datadog, Lighthouse, or Web Page Test to give detailed breakdowns of the rendering performance across different devices and network speeds. And once we find the problems, areas that we can improve, then we can be able to fix them. And one of the biggest performance killer is unnecessary component re-renders. So in React, if a parent component re-renders, all of the children will re-render too unless we prevent it. So the way how we fix it is we can be able to use Memoization Hooks. We can be able to memoize the components. For example, we can use React Memo, where we can be able to memoize the component so that they only re-renders if the props change. And we can also use useCallback, which memoize the functions to prevent the unnecessary function recreations. Then we can also use useMemo to cache the expensive calculations of a function to avoid recompute them on every renders. And we can also use Chrome DevTools and React Profiler to visually see which components are causing unnecessary re-renders. And of course, if our application loads too many components at once, then users have to wait longer before they can see anything displayed on the application, which could be frustrating on the consumer side. So the solution to this is we can use lazy loading. So instead of loading everything up front, we can choose to load components when the user needs them. For example, let's say we have a dashboard with charts and analytics. So instead of loading everything all in once, we can lazy load the charts and analytics if user click onto it. So now the chart and the analytics won't load until they need it, which reduce the initial bundle size and making the application feel much faster. So then once we prevent the unnecessary re-renders and lazy load components, here's some extra things that we can be able to improve the performance. Things like reduce the JavaScript bundle size using tree shakings to remove the unused code and split bundles for faster page loads. Or we can also use skeleton screens or spinners or notifications to make our application more responsive. And we can also optimize for mobile and accessibilities to make sure that our application works well for all users and small screens. Alright, so once we improve the performance on the client side, then we can talk about the API optimizations and caching, because our application is going to communicate to APIs and servers. And if our application is making too many network calls, it also slows things down. So let's fix that next. Now we can also use state management to reduce the number of requests made from the front end to the back end by caching the data on the client side. So in traditional application, maybe we have a client which sends a GET request to the server to get a list of training data. And then let's say say if the client decides to delete a training, or maybe for example add a new records or update a new records, then it's going to send a update operation to the server. Then it might also send a follow-up request to get the new list of training data. Then you can see here that we're sending a lot of repetitive GET request calls to get the trainings data, which we can simply just cache that data from our client side. And that's why we can be able to use state management to reduce the number of calls. And what we can do is we can be able to save the data inside of our state management so that whenever the client is going to render this data, we can be able to use that data from the cache. And the cache data is coming from the response from the server, right? So for example, at first we might have like an empty list for the trainings. And then when the client sends a GET request to get the list of trainings from the server, then the server is going to return us the data. And here you can see we are using an interceptor. So every time when we send a request, we're going to attach the JWT tokens in the headers to authenticate ourselves in the server. And every time when we get a response from the server, we can also be able to intercept it, and we can be able to take this response and save it in our cache. So the client can basically just read it off of the cache data, right? Or the data from our local storage or state management. So in this case, every time when we make a delete operation, after we delete it, we simply just modify what we have inside of our cache. So in this case, we used to have 3 objects, but now we just only have 2, right? And we don't have to send another GET request to the server to get a list of new training data that we have, because we already have those things, right? Now, obviously the data might not be in sync, right? There could be a situation where we are deleting a request, but on the other side of the world where maybe someone is also adding a new records, right? So maybe the data here, it might be stale. So in that case, we have to decide on how we're going to keep our data up to date, right? Maybe by setting an expiration on our cache. So maybe after a certain period of time, we're going to refresh the data. So maybe that's something that we can decide. But all in all, you can see that by using state management, we can reduce the number of calls being made from the client to the server. Now, speaking of setting expiration on data coming from the API, we can also use the use query from the React query library to basically make our API calls. Like for example, here we have use queries, and we're basically calling the fetch data to fetch the data that we need. And then here you can see once we have the data, we can be able to consume it and render this data on our client application. But we can also setting a stale time, which is a expiration on when we're going to make another call to the API. So for example, this is our user interface. And then when we send a query, we're going to see if it's a valid in a cache. If the data has not been expired, then yes, we can be able to return the data that we have already fetched. If not, we're going to retrigger another call. Then once the data is being returned, then we can be able to store this inside of our cache. So you can see that this process can also reduce the number of calls we're going to make to the API by setting an expiration time for the data to keep our data up to date. Now, setting expiration on the data that we fetch from the API are great, but we can also be able to reduce the size of data that we fetch by reduce the overfetching data that we receive from the API. For example, we can be able to use tools like GraphQL to be able to reduce the overfetching data. For example, let's say we have a product like this where we have name, price, stock, image URL, but we can be able to reduce the size of data that's being returned from the API to the client by specifying the properties that we need. For example, we only need to know the price and the name of the product, and anything else we don't really need to render on the client side. Then we can be able to use a GraphQL query to specify that. And GraphQL Apollo client also supports in-memory caching as well. So for example, if we were to send a request to get books, then if the data is not being found in the cache, then we can be able to send a query in the server to fetch the data and store it in the cache. And let's say if later the application execute the query again to fetch the book for this book ID is equal to 5, then if the data is already found in the cache, then we can be able to simply just return the data from the in-memory cache back to the client and be able to render this data. And this way we can also be able to reduce the number of calls being made from the client to the server. And of course, if you're interested in more GraphQL tutorial videos, on my channel, I do have a playlist called GraphQL, which you can see all the GraphQL tutorials that I have made in the past. Things like authentications, pub/sub, filters, and paginations. So if you're interested, please check it out. Now, it depends on the system that we have. We might also want to add rate limiting to reduce the number of calls being made from the client to the server. And you can think of rate limiting as debounce or throttle. So basically we want to wait until the user finishes triggering an event before executing a function. So given like, for example, we're adding a search bar, and because for every keystrokes, we're going to send a query to the server to fetch the recommended results, then you can see that we're sending a lot of API requests to the server. So what we can do instead is we can be able to reduce the number of calls made from the client to the server by using debounce to reduce the number of calls. So you can see here that we have a component and we have our state, and here's our input. So every time when there's unchange for the input, it's going to trigger the handle unchange. So when we try to fetch the results for the API, you can see that we're using a debounce from Lodash. We're going to wait 500 milliseconds after user stops typing. Then we can be able to call the API to fetch the results. And this way, by waiting until the user finished triggering events to execute the search, we can be able to dramatically reduce the number of calls being made from the client to the server. Now, obviously, adding debounce or throttle can also be done on the server, but we can also prevent this happen on the client side as well. Now, lastly, we also want to talk about how to add filters and paginations to our applications to reduce the amount of data sending from the server to the client. So you can see here, let's say if we have an e-commerce store and user can be able to select different types of product they're searching for example, shoes, then the server will filter data that the client wants to see. And also adding paginations so that clients want to see more data, they can navigate to different pages to see more. But of course, for pagination, there's offset pagination as well as cursor pagination. And each of approach has the pros and cons. For example, we could use a offset pagination, which takes the page size, which the total number of items will be displayed on the page, as well as the current page number. Then we're going to send this data to the server, and the server will basically fetch the data. And here we're using the offset and limits from SQL to basically offset the number of items that we want to skip. For limits, it's going to be how many items we want to take. So once we have the data for the current page, then we can be able to send back to the client. Now this approach is great because it allows clients to view the total number of pages, and clients can be able to jump to a specific page by passing the page number. Obviously, the disadvantage for using this approach, so let's say if an item in the previous page was deleted, there might be a situation that the data will be shifted forward, or if there's an item in the previous page added, then the data will shift backwards, which causes some results to be duplicated. And that's where the cursor pagination comes in. And here you can see we're sending a GET request to the server to fetch the next 10 items based on the cursor ID that we have. And the cursor here is going to be a sequential ID, or it could be a timestamps or any sequential elements that we have. And for example, if the ID is 1234, then we can be able to paginate through the cursor. So we're going to find IDs that are less than or equal to 1234, and then we're going to order the ID by a descending order. Then we're going to take 11 items, and the reason why we take 11 items here is because the next cursor is going to be the 11th item. So the clients can be able to use the next cursor when they want to load more data, as well as they can be able to see if there are more data to load. But at least you can see that with cursor pagination approach, we do see a stable reference point. So if there's any additions or deletion of records, will not affect the pagination window. And this also reduces the load for the database because it jumps directly to the record without iterating through the unwanted data. But obviously the disadvantage for using this is that cursor pagination does not allow clients to jump to a specific page, and the cursor here must be unique and sequential. For example, it could be a timestamp or a sequential ID. But all in all, you can see that by adding filters, either offset paging or cursor paging, we can be able to reduce the amount of data sending back from the server to the client to improve the overall system performance. Alright, so to conclude everything, we just covered 14 essential front-end system design concepts that can dramatically improve your application performance. Now, which one was your favorite? Please let me know by commenting down below. And also don't forget to check out my other videos, and I will put the links in the description below. So if you found this video helpful, please make sure to hit that like button and subscribe, and I will see you in the next video.